My name Praveen Uma Mageshwari Sendil Kumar. My student ID is S41555669.
This is my student ID. My full name is Sadakshi Balaji and my student ID is S407 2007.
Hello, we are presenting dynamic malware analysis in a controlled environment. In this video, we will briefly explain how we completed question 1 where we executed the suspicious malware simple inside a Windows virtual machine like Race VM, monitored its behavior using Process Hacker, Process Monitor, Rexshot, and Wireshark, and identify indicators of compromise. This video is a short explanation of the steps we documented in the report. Step 1. Initial system setup. First, we prepared the Windows virtual machine for the safe malware analysis. We confirmed that the analysis was done inside the VM. Because the assignment especially requires that all tasks to be performed in a virtual machine, like using the classes, race VM, RMIT, then we collected the initial system information before the executing the malware. In our case, we recorded host details and networking information using commands such as hostname, OMI, system info, IP configuration, and netstats ANO. We also installed and opened the required monitoring tools, Process Hacker for process observation, Rexshot for before and after registry comparison, Process Monitor for system activities, and Wireshark for network traffic captures. This matches the workshop guidance for dynamic malware analysis. Step 2. Baseline before executions. Before running the malware, we took a baseline snapshot of the system. In Rexshot, we captured the first shot so we could later compare registry changes. In Process Hacker, we checked the currently running process under the explorer.exe to understand the normal process state before executions. In Wireshark, we started packet capture on the active Ethernet interface before the launching the sample. After the step 3, malware executions. After the environment was ready, we extracted the malware sample for the question 1.zip in the question assignment 2 using the password infected provided in the assignment and they executed the malware inside the Windows VM. We allowed the sample enough time to perform its action so that monitoring could capture meaningful behavior. Step 4. Registry activity analysis. After execution, we turned it to Rexshot, took the second shot, and compared it with the baseline. This allowed us to identify registry changes made after the malware ran. The comparison output showed a large number of registry modifications, which indicates that the malware changed the system state after the execution. This is important because registry modifications are often linked to persistence or system configuration changes.
So step 5, process activity analysis. So for this process analysis, we use Process Hacker and Process Monitor. So in Process Hacker, we observed a suspicious executable running as job clock administration applet, which appeared from the downloaded malware path rather than a trusted Windows directory. So this makes it suspicious. So in Process Monitor, we use the process tree and identify additional related activity, including short-lived child processes such as WMI provider host. Step 6, network activity analysis. So this behavior is important because malware may query the metadatabase service to collect cloud instance details or temporary credentials. We also reviewed source and destination IP addresses. So this network evidence is valuable because the assignment rubric expects clear identification and analysis of network activity, not just screenshots. Step 7, file activity analysis. So this step is important because malware often copies itself, creates temporary files with system folders to maintain persistence or stage additional activity. So by examining the file paths together with the process name and timing, we can better understand the malware's behavior. Step 8 is overall behavior and severity. So based on the combined evidence, we assisted the malware as highly suspicious and potential critical because it executed from a controlled user path, triggered system changes, and initiated unusual HTTP activity to the metadata service. So this conclusion is supported by the documentation, outputs from the monitoring tools, and the step-by-step screenshots in our report. So this concludes our short demonstration for question 1. Thank you.